In order to block the development of China's AI technology, the United States even gave NVIDIA the H20 version specially given to the Chinese Special Communist Party. The US Department of Commerce also added 3 articles to their export control regulations. This article is not allowed to use American chips to run China's AI model. Otherwise, you will be warned that this article is to prevent American chips from being purchased from other places and then transferred to China. The most outrageous thing is this one. You are not allowed to use Huawei's Ascend chip anywhere in the world. Attention, this is anywhere in the world, including China in China.
You are not allowed to use Huawei's chips, not the United States. This hand is a bit long. No matter whether you use American chips, you still want to block Huawei's chips. The reason why the United States is targeting them is probably because Huawei has found a way to use Shengteng's way to replace American chips. Not long ago, Huawei Cloud used 384 domestically produced Ascend AI chips to connect each other. I can't use so much, so I just use 5 meanings to form a whole. The full name is Cloud Metric 384. The supernode can already be used with NVIDIA. 72, the strongest GB 200. The interconnected NVL7 2-point play has been played back and forth, and many indicators are even higher. That is to say, to run large models in the future, you don't have to use NVIDIA cards and domestic cards. However, some netizens are wondering, there are more cards to win others, isn't there any technical content? Today, I will give you a simple explanation of the doorway and why Huawei's route of large-scale card stacking is more suitable for China. First, ask a question, is it faster for 2 chips to work together than for the same chip? Not necessarily, because if these 2 chips communicate very slowly and he is still assigning tasks or transferring money, what will happen? Every chip has already been finished. 2 are not necessarily faster than 1, and even 10 are not necessarily faster. Therefore, how many examples can be piled up by stacking chips is a technology in itself, or the large model is getting bigger and bigger, with hundreds of billions or even trillions of parameters. In most cases, many cards are needed to form a whole through ordinary communication to run a large model, which will lead to a one-on-one challenge. I may not be able to beat you, but sorry, it is now. Can the chips of the times be piled up? The key to how many % of the calculation examples each chip can actually play in the cluster is the communication speed between the chips. Most of the time, the various hardware in the computer is interconnected by something called PCIe, which is equivalent to the ordinary road in the computer. This road is usually very useful, but when several GPUs are connected together, it requires very ordinary transmission of data to each other to do the same thing, and the bandwidth of PCIe is not enough, and PCIe is a master-slave architecture, that is, the CPU transmits data to the master. If his equipment like Waterbugs wants to communicate with each other, it must first get the consent and arrangement of the owner, which will of course slow down the speed. So in 2014, NVIDIA poured out a dedicated interconnection channel between GPUs called NVLink and made an NV switch based on NVLink, which allows more GPUs to directly peer-to-peer interconnect without CPU arrangement. The transmission speed is also more than 10 or even more than 20 faster than PCIe. Why is the version of H20 for Chinese agents less than 1/3 of the H100 that American companies can buy directly? Domestic companies still rush people to buy it because NVLink high-speed interconnection can be used to make the calculation example of stacking cards more profitable. However, NVLink also has 2 minor problems. First, only NVIDIA GPUs can use NVLink GPUs to interconnect with other things or PCIe, and GPUs often require CPU participation. It is inevitable that PCIe will be used to slow down the overall situation. Speed. Second, NVLink has a pass. Limited GPUs that are connected to each other. If they are on the same circuit board, they usually use the wires on the board. If they are different circuit boards, they usually need to be connected with copper plates. In the case of high-speed transmission, the signal exceeding 1 meg will be extremely degraded, just like Bluetooth headsets will be stuck and disconnected when they are far away. Therefore, if NVIDIA wants to stack GPUs, it can only be compressed into a small space as much as possible. For example, the 72 strongest GB 200 units are connected to each other in such a cabinet with NVLink and used as a whole. This is the best NVIDIA can hand over at this stage. Donate, because it is much more powerful than ordinary servers. It is called a supernode. It's not that NVIDIA doesn't want to stack more, but it can only stack more than 72 chips at present. For example, if 2 operating nodes want to be interconnected, it can only travel long-distance transmission networks, such as InfiniBand high-speed Ethernet, which is faster than NVLink. So how does Huawei do it? Pay it in first. In 2019, the United States began to sanction Huawei. At that time, the PCIe standards organization led by American companies immediately cancelled Huawei's membership for general use. IE will be very troublesome. Huawei has no choice but to make a set of communication solutions by itself to connect various kinds of communication solutions. However, precisely because it is a brand new set of communication solutions, there is no historical burden. Instead, it allows Huawei to let go of his palm and send it back. Your biggest advantage. What advantages? Optical technology. Huawei uses optical modules like this to connect to the chip to translate the electrical signals generated by the chip into optical signals, and then use optical fibers to transmit them, thus realizing The optical homogeneity between them can be accumulated to several hundred GB per second through multiple parallel frames, which is faster than NVLink, and various GPU, CPU, NPU chips can be used. In terms of architecture, everyone is also completely equal, unlike PCIe, which needs to be based on CPU, but the most important thing is that it is not limited by distance. It can be used in a chassis, between cabinets, across computer rooms, or across computer rooms, so it can be connected. More chips form a larger scale operating node, achieving overall energy transcendence. Hey, such a one uses 384. The Cloudmetrics 384 supernode obtained by chip interconnection is the current rollup produced by Huawei Voice. According to the report of Semi-Analysis, a professional analysis organization, Huawei's supernode computing power is more than twice that of NVIDIA. This strategy of playing more and playing less allows Huawei China to now have AI system capabilities that surpass NVIDIA, and the chip scale of 384 has some additional benefits such as natural running to MOE models such as DeepSeek. You see, DeepSeek is composed of 256 expert models if it runs in. In a supernode composed of 12 cards, several experts must gather in one card to grab resources from each other. If they are distributed in several tidal nodes, they will bring communication delay. However, running in a super festival ceremony composed of 384 cards can run an expert on a card, which is more efficient. Alas, who would have thought that the natural transmission scheme that was forced by the United States had no choice but to become the most favorable return machine for Huawei Cloud in the AI era? Hey, some people may want to ask, why does NVIDIA not use optical modules to stack more chips? Do you think I won't go to Tsinghua because I don't want to? In fact, NVIDIA planned to use optical communication to connect 256 H100 chips in 2022, but later gave up. The obvious reason is that optical mode is too expensive and consumes too much power. But in fact, the more important reason is that optical communication is a hunting horse, which is very difficult to drive, and optical communication is more prone to failure. What socket should I go to? The optical fiber is a little bent, or the plug is open. All kinds of situations may affect communication. In comparison, Tonglen is just like a cow, with a good temper and solid skin. If NVIDIA wants to use optical macaroni, it has to purchase optical module, optical fiber from other companies. This thing is easy to break, and there is a way to make it yourself. It is also very troublesome to maintain the empty quality later. So NVIDIA finally decided to settle for next best thing. Hey, let's simply use Huawei to say, optical communications, hey, I'll accept this thing. Huawei was originally a communications professional. It was making network switches in the 1990s. Around 2000, Huawei's optical communication technology. Huawei's optical transmission achievements have already led to international leadership. If we consider previous examples of Huawei's light transmission efforts, they could circle the globe multiple times. Such feats require extensive experience and technology. For instance, before optical communication fails, the optical module might be in a sub-healthy state. Huawei Zero uses AI algorithms to assess sub-health based on power, current, voltage, and temperature, proactively replacing channels in Guangdong before failure, then applying anti-bamboo shoot technology to minimize failure. Just like if a lane breaks down, usually the entire road may be paralyzed by traffic jams. However, Huawei Cloud can temporarily close this road and coordinate other lanes to reduce the number, to keep the whole road smooth and prevent model training from being in the middle stage. According to Huawei's official statement, the failure rate of optical mode can be greatly reduced through anti-loss technology. The model training is stable for more than 40 days without interruption. In addition, once a failure occurs, dynamic stress testing technology can be used to quickly locate which node is running slowly through 10,000 failure modes. What happened to trigger the corresponding self-cultivation strategy and achieve automatic recovery in minutes? There are many such examples, all of which rely on countless engineering experiments and stepping on pitfalls. Therefore, light permeability may be a horse hunting for NVIDIA, but it is completely a cinch for Huawei. What's more, Huawei provides calculation examples by ascending AI cloud services. Customers don't have to think about light permeability maintenance at all, and if 384 chips can't be used so much, they can use as many as they want. As for the optical module function, the problem is that China is the world's largest energy producer and the largest clean energy producer. Using a little more electricity is better than developing AI technology and depending on the face of the United States. So when you look back, you will find, NVIDIA relies on stronger single cards to put the calculation into a smaller space, while Huawei relies on stronger communications to pile up the number of cards larger. I think these two routes are related to the differences in industrial soil softness between China and the United States. NVIDIA's super single card capability was first calculated by 3D games and images in the United States. Huawei's communication capability is a country with a super high fiber-to-the-home penetration rate in China. Since 1991, it has vigorously developed fiber-to-the-home penetration rate in China has reached 90%, while only 30% of the historical development track in the United States has determined that we are better than our opponents, so there is no need to follow the rhythm of others, and we can also reach our destination.